Okay, so let's talk about redox reactions, balancing them, and then calculations. One thing that I would just like to mention is that an oxidizing agent is a substance that oxidizes other substances, but it gets reduced. And reducing agents are reducers that reduce other substances but get oxidized. So just remember that, but that you don't really need to know when doing the balancing. Well, you do need to know it for balancing, but yeah. Okay, so our question is, you have 0.2640 grams of oxalic acid. It is dissolved in a flask, and 10 milliliters of sulfuric acid is added to it. Mixture requires 30.74 milliliters of potassium permanganate solution from a burette to titrate it and cause it to change from colorless to pink. So when we get a question like this, first of all, we need to balance the equation, because you have to balance because you need to know the ratio between the two substances. So let's start here. We have the potassium permanganate, KMnO4 plus H2C2O4. This will lead to something. So when we balance redox reactions, we need to know the charge, and we need to balance the charges. So what we do is called half reaction equations. So we just write, this is in an acidic environment. This is important. Let's just say environment, like so, whatever, equals something. So when you read potassium permanganate, you can be 99% sure that this is the oxidizing agent. You can be sure that this is the oxidizing agent. Now this, when we write half equations, we know that this is the oxidizing agent. So we look at this side of the standard electrode potential table, and then we can see here that this is our oxidizing agent, and because this is an acidic environment, then we have to take this whole equation because it's an acidic environment. But had it been potassium permanganate in a basic environment, then we would have took this one. But anyway, so this will be our oxidizing agent. So when we write half equation of this, then what we do is we take this exact reaction. So MnO4 minus, which will be this one, plus 8 hydrogen plus 5 electrons equals Mn2 plus 4 H2O. So that will be oxidizer, or let's just say oxidizer, and then the reducing agent will be this one. So you look at, because this is the reducing agent, then you have to look at this side of the table, and it's H2C2O4. And you can see here we have H2C2O4, and you just write the half equation now for this guy, like so. So you write H2C2O4, and then in reducing agents you write the electrons on the right side of the equation, and in the oxidizing agent you write the electrons on this side of the equation. Now this doesn't really matter a lot, but if you want to write this correctly, then that's where you write it. And I don't know if on colloquium the teacher will be harsh on that or not, but just to be correct, this is where you write the electrons. So yeah, now we have our half equations of this one and of this one. So what we do now is that we have to look at the electrons. We have 5 electrons here, we have 2 electrons here. So this means that we have to multiply everything here by 5, and we have to multiply everything here by 2. So what we get is, oh yeah, and after that you have to, these guys will be, this side will become the left side, and this will become the right side of the new equation when we balance. So 2 times MnO4, you will get 2MnO4 minus plus 16H plus 10 electrons, and this, and then you have to do 5 plus 5H2C2O4, and this equals 2Mn2 plus, let me just, this 2Mn2 plus 8H2O plus 10 CO2 plus 10 hydrogen plus 10 electrons. Now that we have 10 electrons here and 10 electrons here, then everything is equal. So now we just have to make this reaction shorter. So you write 2MnO4 minus, because, yeah. And then you have 16 H's here, and you have 10 H's here, so these will cancel out, and then you will have 6 hydrogen left. So plus 6 hydrogen left, and these ones you just strike out. And then you only have 5H2C2O4, and this equals 2Mn plus 8H2O, and then 10 carbon dioxide. Okay, and now you have a balanced reaction. This is how you balance redox reactions. Now, to the next part of our thing is, I will actually just move this. Here. So now that we have a balanced reaction, we can actually start our calculations, and we can start them now because we have a ratio. We have a ratio between this one and this one. And so this is the easiest way to do these calculations, and you will never fail if you do it this way. So what you have to do is you write a table here. So you have ratio, and then you have moles, and then volume, and then concentration. Yeah, like so. Okay, now that you have your table, you have to fill this table with every single bit of information that you have received. Yeah, let's write mass as well, because we have got mass here. So the first thing here is that you have to fill with this table is the ratio. You have 2. These ones we don't care about them. Don't care. The only thing that they tell us is that it's an acidic environment. So, They are important a little bit because of the 10 milliliters, but yeah. And so, but what I mean, we don't care about the 6 here, or the ratio. We care about this ratio. So it's a 2:5 ratio between potassium permanganate and oxalic acid. And this reaction right here, I don't care about as well, or the products I don't really care about. Anyway, so we start to fill out the information. We know that we have this amount of mass of this one. So we look here, then we write 0.2640. Then we look at the next thing. They say that we have 10 milliliters, so this amount has been dissolved in 10 milliliters of sulfuric acid is added to it. So this means that there is 10 milliliters, 0.01, so we have to write this in liters, we can't have it in milliliters. So 0.01 liters, and because this one, so the volume of this one will also be 10 milliliters because this is a mass that has been dissolved in 10 milliliters, so the volume of this one is 10 milliliters of the oxalic acid. Yeah. And then we have a mixture requires 30.74 milliliters of potassium permanganate from burette to titrate it and cause blah blah blah. So basically we have 30.74 liters of potassium permanganate. Do we have anything else? Okay. Now there are a couple of things that we can do. If we look at the table, actually because they have given us mass, then we can calculate, then we can also look up molar mass. And the molar mass of H2C2O4 is, let me just look it up. So the molar mass for it is 90.03 grams per mole. Okay, so now that we have this one and we have the mass, this means that we can know the moles of this one. And so the moles is M times M, so 0.2640 times 90.03, which equals 23.76. No wait. N equals M divided by M, my bad. 2640 divided by 90. Yep. And now that we have the amount of moles for oxalic acid, then we write 0.0029. Okay, now we look at our table again. Let me just clean this up. Okay, so now we look at our table, and then we can see that what we want to know, well, actually the question hasn't been put, but what's most commonly is like, what's the concentration, whatever, moles or whatever of this one. But basically you have your table, and then you start to look at what do I have, what do I not have. And you have the amount of moles of oxalic acid. That means that you can calculate the amount of moles for potassium permanganate. And if you have a 2:5 ratio, well, then that means that you just have to use the ratio of 2:5 to calculate this one. So you do that by, well, if you want to know the ratio for this one, you take the number 2, and then you divide it by 5, and then you multiply it by this one times 0.0029, and this equals so you write how many moles you have here. So that's the answer. Now you look at your table again. I can calculate the concentration for this one. I could calculate the concentration for this one. And it depends on what the question is really, because now that you have the amount of moles, you have the volume, you can calculate the concentration, which would be C equals n divided by v, and n you know is this one, and v you know is this one. So you divide that by, let's do that, by 0.03074, 0.03074, you get 0.038, 0.038 mole per liter. If the question asks for whatever, for the mass or whatever, you could calculate it. But here they would most often ask about the concentration, and now you have the concentration. You could also calculate the concentration for oxalic acid if that would be interesting for you. But always make a table, and always make a table of the amount of moles, of the volume, concentration. If they give you the mass, put the mass in. And molar mass you can always find in the data booklet. And just fill out the information that they give you. You write these things, and then you just fill in the information. Just look at what they're giving you. They're saying this amount of grams of this substance, so that you don't mix. So you don't write that you have this mass for potassium permanganate. You just have to read the question clearly, and then you just fill out the information. And then as you're filling in, you look at, oh, what do I have? Okay, I could calculate the amount of moles of this one. Okay, but if I calculate the moles of this one, what else can I do? And then you just fill out the table, and voila, you've answered all the questions. So this is basically the easiest way to do calculations in chemistry. Yeah, and if you have any questions, just ask me. Also, look at the description box, because if I have made a mistake, then I will just write the correct answer or restate whatever I said in the description box. So, yes, thank you. Bye.